Ever wondered how pig iron is made? It's a question that may not cross your mind often, but the answer is more intriguing than you might imagine. Pig iron, a raw form of iron, plays a crucial role in various industries worldwide. It serves as the backbone of steel production, a material we rely on for everything from skyscrapers to cutlery. The process of creating pig iron is a fascinating journey of transformation. It begins with iron ore, a naturally occurring mineral found in abundance across the globe. This ore undergoes a series of complex chemical reactions, resulting in the formation of pig iron. The creation of pig iron is not just a simple conversion, it's the first step in a chain of processes that give rise to countless everyday items. The intrigue of pig iron lies not only in its production, but also in its potential, its ability to become something much greater. So how does this transformation of iron ore into pig iron occur? Stick around to find out. Before we dive into the process, it's important to understand the basic components required. At the heart of pig iron production are three key ingredients: iron ore, limestone, and coke. Iron ore, as you might have guessed, is the primary source of iron. It's loaded with iron oxides, which are essential for this process. Then there's limestone, a natural resource used as a flux in the process. The flux's primary role is to remove impurities from the iron ore, ensuring a higher quality end product. Finally, we have coke, a product of coal. In pig iron production, coke serves as the primary fuel source. It burns with intense heat and little smoke, making it ideal for the process. Moreover, it also helps in reducing the iron ore to molten iron. These three ingredients, each playing a crucial role, come together to create pig iron. Now that we've got the ingredients, let's move on to the process itself. The heart of pig iron production is the blast furnace. This colossal structure plays a pivotal role in the transformation of our basic components into pig iron. Imagine the blast furnace as a gigantic cylindrical tower, lined with refractory bricks capable of withstanding incredibly high temperatures. It's within this furnace that the magic truly happens. To begin with, our raw materials, iron ore, coke, and limestone, are introduced into the furnace from the top. As these ingredients descend, they encounter a blast of hot air introduced from the bottom. This hot air blast ignites the coke, creating the intense heat needed to melt the iron ore. Simultaneously, the limestone acts as a flux, helping to remove impurities from the ore. This smelting process, fueled by the furnace's heat, results in molten iron, or pig iron, which is then tapped off from the bottom of the blast furnace. So, we've got our furnace ready. What's next? Let's find out. The smelting process is where the magic happens. A captivating dance of science and industry, it all begins with the careful layering of components inside the blast furnace. Iron ore, limestone, and coke, a form of carbon, are meticulously arranged in layers. Once the stage is set, the furnace is heated to staggering temperatures, reaching up to 3,000 degrees Fahrenheit. This intense heat triggers a series of chemical reactions. The iron ore, a compound of iron and oxygen, begins to break down. At the same time, the limestone reacts with impurities in the ore, forming a waste product called slag. Meanwhile, the coke reacts with the oxygen in the ore to form carbon dioxide, leaving behind pure iron. This iron then combines with the remaining carbon and other elements, resulting in a dense, malleable material we know as pig iron. And voila, we have pig iron. But what does it look like and where is it used? Oh, we've produced pig iron, but what exactly is it? Let's delve into that. Pig iron, a high-carbon iron, is rather raw and unrefined in nature. It's characterized by a metallic gray appearance and a brittle structure, which makes it unsuitable for direct use. However, it holds a vital role as the primary ingredient in the production of steel, the backbone of modern infrastructure. Pig iron undergoes a process of decarbonization to produce steel, which is a much stronger and more versatile material. This transformation is what makes pig iron so indispensable. The applications of pig iron, and by extension steel, are practically limitless. It's used in the construction of skyscrapers, bridges, and vehicles. It's in the cutlery you use to eat your meals, the surgical instruments that save lives, and even the coins jingling in your pocket. So, the next time you see a steel structure or use a steel utensil, remember the crucial role of pig iron in its creation.